like, share, subscribe.
Hey y'all, welcome back. Let's take a look at tonight's homework. We're looking at these different polynomial functions, and it looks like we're trying to match them with the graphs. So what we'll do is try to narrow it down based on the end behavior and the number of zeros of each of these functions and see if we can't make some matches here. So the first one is a linear function, okay? It's got a y-intercept of 3 and a slope of -2. Are there any other linear functions on here? It doesn't really look like it, so the only possible choice here would be C. Okay, and you can see, yes, the y-intercept is 3. It's got a negative slope. Hard to tell exactly what it is, but it doesn't really matter since it's the only possible choice here. So this is definitely going to be C. And so I guess what I'll do here is just kind of X these out as we use them. Okay, so we got C. Number 2 is x squared minus 4x. Okay, so this has an even degree, and it has a positive leading coefficient. So we know it's going to be going up to the left and up to the right. And the zeros here, if I factor out an x, and I get x times x minus 4, my two zeros should be at 0 and 4. So that's kind of what I'm looking for here. So the only ones with 0 and 4, I think I found it right here. So you've got a 0 at 0, a 0 at 4, and we can see that the end behavior is going up and up. So the answer to this one is going to be G. For number 3, we've got another quadratic, so we're going to be looking for a parabola. But in this case, the leading coefficient is negative. So the degree is even, the leading coefficient is negative, so the end behavior is going to be down, down. And as far as the x-intercepts are concerned, we can only factor out an x here. Be left with -2x minus 5. So the two x-intercepts are going to be at 0 and at 5 halves, or 2.5. So 0 and 2.5. So let's see here. I'm not seeing one like that. Oh, wait a minute. Hold up. Was it -2.5? Oh, yes. I'm sorry. It should be -2.5. Add 5 would be positive 5 divided by 2. See, that's what I get for not really showing my work there. So yeah, the zeros here are going to be at 0 and -2.5. The end behavior is down, down, so H is going to be our answer for that. Number 4 is a cubic. Now, the factoring is going to get a little trickier here. In fact, I don't even think we can factor this one. But because it's cubic, so it's got an odd degree and a positive leading coefficient, we know the end behavior is going to be down, up. So let's see if we can't at least narrow this down, and if once we narrow it down, we can see what else we can look at. So the ones that are down, up might be F, might be B, and it looks like those are our only two options here. So let's take a look at the y-intercept. So our like if I plug in 0 here, so 0 and 0, I get 0 plus 1. The y-intercept is 1, and so we see this one has a y-intercept of 1, so it may be F. This y-intercept is 0, so it's got to be F. So this right here, the constant is always the y-intercept, okay? Little trick there. That's true for all of these polynomial functions. You know, like we looked at this linear one, we found the y-intercept. Okay, so let's look at 5. Now 5 is a quartic function. It's got an even degree and a negative leading coefficient, so we know it's going to be down, down. And it looks like we can factor this one. We can factor out an x squared and get -1/4 x squared plus 3. So what would the zeros be here? We would have one at 0, and that would be a multiplicity 2. Okay, so multiplicity 2 meaning we're going to have a bounce at the origin. And the last one would be positive 12. Yeah, I think, a square root of 12. So it's a square root of 12, a little over 3. So take 3 point something. But let's see if we can't narrow it down here, just based on this information that we have here. So we're looking for down, down. This one's down, down. That could be it. We do have a bounce at the origin. And we've got, let's see, 2, 3. It looks like it's going to be A, but let's see if there's another choice here. Nope. Nope. Yeah, so it's got to be A. For number 6, we've got an odd degree. So we know that the end behavior is going to be going in opposite directions. And since the leading coefficient is negative, we know it's going to be up to the left, down to the right. No factoring here. We know it's cubic, but let's see if we can narrow it down here. Up to the left, down to the right. It looks like, yeah, our only choice here is going to be E. We could have checked the y-intercept, which is going to be negative, like 1.3, and yeah, since this is -2 right here, that seems to check out. So yeah, the end behavior here is up to the left, down to the right, and then we've got that y-intercept there. So we're just down to B and D. Number 7 here is a quartic. So we know it's going to, and it's got a positive leading coefficient, so it's going to be up, up. That kind of gives it away here. But let's just, this one's factorable, so let's go ahead and factor it. X cubed is the GCF. And so we've got x to the 4th, oh, not x to the 4th, my bad. Just x plus 2. So we get 2 x-intercepts, one at 0, one at -2. But this one at 0 has a multiplicity of 3, so we're going to see a bend behavior at the x-intercept. And that's what we see right here. We see the x-intercept of -2. Notice how the graph just goes like straight through. It just passes straight through that 0. And then the x-intercept at 0, we have this bending behavior where it like almost looks like it wants to turn back around, but decides it doesn't want to and continues on in the positive direction. And the end behavior matches up with the up, up. So this one's got to be D. And just using process of elimination, the last one should be B. Just one quick thing I want to check is the end behavior, just to make sure we didn't make a mistake here. We've got an odd degree, positive leading coefficient, so the end behavior is going to be down, up. And that's what we see here, okay? So yeah, there we go. Looks like we've done all the matches now. So let's move on to the next page. So here we are trying to write the polynomial in standard form and then describe the end behavior of the graph. So we don't actually have to graph these yet. We're just going to rewrite them and then use the leading term to determine what's going on with the end behavior. And I know in the last section I was pretty casual about how I named it. Like I didn't even write out what was happening. I just kind of drew arrows. That can help with the matching if you're just trying to move quickly. But I'm going to describe the end behavior a little bit more appropriately. I'm going to use the infinity notation to describe, say, like as x goes to infinity or whatever. Yeah, so let's go ahead and look at number 9. So for number 9, it's not in standard. In fact, I don't think any of these are standard form. So standard form means that we're going to rewrite the polynomial so that the term with the highest degree or exponent comes first. And when we have more than just 2 terms, we'll write them in descending order. So largest exponent first, and then we'll move down from there. Now here we've got just make the 2 things I'm looking for. So this one's got an even degree, okay, 6, and then it's got a negative, oh gosh, leading coefficient. Did I spell that right? Coefficient, I think so. But yeah, so the 2 items are the degree and the leading coefficient. That's really what you want to look for. And that'll tell you what the end behavior is. So when that happens, the end behavior is going to be down, down, okay, down to the left, down to the right. And the way that we are actually going to write that is as x approaches, and so we'll use like a little arrow here. I think I can copy one from... yeah, there we go. So as x approaches infinity, I guess we'll start with the left. So the left will be, as x approaches negative infinity, the function goes down. So f of x will approach, put some spaces in here, make it look a little nicer. So yeah, as x approaches, let's get a bigger minus here. I really want to make this real obvious. Okay, so as x approaches negative infinity, f of x will approach negative infinity. Okay, because it's going down to the left. Okay, now to the right, it's also going down. So as x approaches positive infinity, f of x is approaching negative infinity. Okay, so this is saying to the left it's going down, to the right it's going down. So here's the polynomial in standard form, and here is the description of the end behavior. For number 10, I'm going to rewrite this similarly to how I did number 9. The largest degree is the 7th degree term, so negative 5x to the 7th plus 2x to the 5th. Really, none of these other terms are going to affect our answer here. The only thing you really need to look at is the first term. Okay, so this first term has, in this case, an odd degree. Oops, deleted the wrong thing there. And it also has a negative leading coefficient. Okay, so since it has a negative leading coefficient, the direction that this thing is going to be up to the left and then down to the right. Okay. So as x approaches negative infinity, the function is going to approach positive infinity. As it goes to the left, the function is going to be moving up, and as we approach the right, the function is going to approach downwards. Okay, so towards negative infinity. So yeah, there's number 10. Here's the function, here's the end behavior. So let me go ahead and box the actual function in standard form. Number 11, okay, it looks like we got to do a little distributive property here. We need to multiply this in, so I'm going to actually do this in 2 separate steps. First, I'm going to multiply this term in here, and then I am going to rearrange the terms to put it into standard form. So first, let's go ahead and multiply that in. Negative 6x squared plus 10x to the 5th. Oh, that'd be minus 4x to the 6th. And so then I'm going to rearrange this and put it into standard form. So the first term should be the negative 4x to the 6th. And then the second term should be this 10x to the 5th. And yeah, then the quadratic term should be last. So this is going to be our function in standard form. Oops. What happened there? Okay, and then as far as the end behavior, we're going to look at the first term, which in this case is negative 4x to the 6th. Okay, we've got an even degree and a negative leading coefficient. So we're going to have the same end behavior that we had in number 9, it looks like. Did I miss something there? Nope, it's going to be the same. Okay, so I don't even have to change anything here. As x goes to the left, y goes down. As x goes to the right, y goes down. Okay, so for number 12, we will do kind of the same thing here. We'll start with using the distributive property. And then we will look at that first term. So here we get h of x equals 6/4. So that would reduce to 3/2. 6/4, 3/2. Yeah, I think that's right. X to the third minus, that'd be 6/12 x squared. Now 6/12 is going to reduce to 1/2. And then minus 3/4. 1 times 3/4 is just 3/4. So this is our function, and it's already in standard form after that, actually. So we're good to go there. And we have an odd degree and a positive leading coefficient. So kind of similar to this number 10, but we actually have a positive leading coefficient. So because we have a positive leading coefficient, it's an odd degree, so the end behavior is going to go in 2 different directions. But since we have a positive leading coefficient, we're going to go up to the left, and down to the left, up to the right. So let's fix all this. So this is a positive leading coefficient. So we will go down to the left and up to the right. So as x approaches negative infinity, f of x will approach negative infinity. And as x approaches positive infinity, f of x will go up, so it'll approach positive infinity. All right, so this little analysis that we're doing here, I'm not going to write all of the, all this little this work on all the problems when we start graphing them, but I think for this section it's good to really, really spell out how we're making this decision, because this is going to affect how we sketch the graph, starting with the next section here. So here where we are actually getting into the sketching and finding the end behavior is just one part of that. We'll find the end behavior based on the leading term. We'll find the zeros by usually factoring and setting the function equal to 0 and solving that way. And then we also find the y-intercept, which will be that constant term. Or if it's not in standard form, we can just plug in 0 everywhere we see it, and so we'll get the y-intercept that way. Now, between the x-intercepts and the y-intercept and the end behavior, we should be able to get a decent graph for all these. So yeah, let's do number 15 here. So for number 15, I guess we'll start with the intercepts and we'll do the end behavior at the end. So in this case, we can factor, okay? So let's go ahead and factor this. F of x equals, and we can factor out an x. So we get x times x plus 5, or x squared plus 5. Oh, okay. So we get x squared plus 5, and so our actually we're going to end up with 3 zeros. We're going to end up with the x-intercepts being 0, and all these will be singles. The x-intercepts will be 0 and plus or minus root 5. So plus or minus, I don't know, let's see, can I get a plus or minus in here? Yeah. Oh, wait a minute. See, this is what happens when I try to go too fast here. Okay, so what we're actually going to do here is we're going to set each of these equal to 0. This one's going to be pretty obvious. But here we've got x squared equals negative 5. So this is not going to produce any real zeros. Okay, so we actually just get one x-intercept at 0, which is actually the same thing as the y-intercept. So we have a point here. And yeah, this one's kind of funky, right? Okay, so let's just look at the end behavior. We got a cubic, meaning that it's got an odd degree and a positive leading coefficient. So we're going to have this scenario right here. An odd degree, positive leading coefficient, so we're going to be going down and up. And so we don't know exactly what's going on outside of this, but we know that it's going to go down and then it's going to come up. Now what's probably happening here, because we've got this imaginary number, is we're probably going to have like another dip somewhere. And we haven't really gone over how to know that, but right now we're just trying to get a general sketch down. Kind of wish this wasn't the first problem because this is kind of a weird one. But yeah, that's just the way it goes sometimes. So this is going to be our rough sketch here. So we want to go directly through. Should be a little bit of curvature here. And there's likely going to be like a local maximum or minimum, but we haven't really talked about that yet. So for now, we just want to make sure it's going down to the left and up to the right. Should not be linear though. Number 16, we're going to, so let's see if we can factor that one. Is that one factorable, or are we going to have to use quadratic formula here? And we didn't label the x and y intercepts, but not much to label here, it's just 0. Okay, so for here we can we factor this? Let's see, 2x, well, if it's going to be anything, it's going to be 2x plus 1, or actually 2x minus 1, because that middle term is negative, and x minus 1. So let's see, would that work? Minus 2x, yep, there we go. So those are our two factors. So we're going to get x equals 1/2. And x equals 1. So those are going to be our two x-intercepts. 1 at, let's see, we'll just put 1 right here, and we'll put 1/2 right here. Our y-intercept here is just 1. Okay, so we are also going to cross the graph right here at 1. And let's see, we've got an even degree with a positive leading coefficient, so that is going to be up, up. I don't think we actually had one like that yet, so I'm just going to copy and edit this. We've got an even degree and a positive leading coefficient here. So we are going to be going up and up. We're going to be going towards positive infinity, whether x is going to positive or negative infinity. So yeah, this is going to be like an up-up scenario. So yeah, the correct way to describe this would be as x approaches negative infinity, f of x is approaching positive infinity, and as x approaches positive infinity, f of x is approaching positive infinity. Yeah, so let's sketch this out. So both of these are just single roots, so we are going to pass through this. And so our graph is going to look, it's quadratic. We're expecting it to be parabolic. So yeah, it should do something like this. Number 17 is already factored. Wow, that's nice. We can kind of skip that step, and we go straight to x equals 0 and x equals 4. Okay, now this 0 is going to have a multiplicity of 2. Okay, so what we know about that is that when it touches the x-axis at the origin here, it's going to bounce, okay, off of the x-axis. Now for the y-intercept, this is not in standard form, but if we were to multiply this out, we would get x cubed minus 4x squared. Okay, so you can see that the y-intercept is going to be 0, which we should have already known since we had an x-intercept that was 0, right? So you can only have one y-intercept for any function. So yeah, we know it's going to be right there. So let's go ahead and plot those two first. So we've got a bounce occurring at 0 and a pass-through occurring at 4. Now the leading term here has an odd degree and a positive leading coefficient. So this is going to be like number 15, where it's going to go down to the left and up to the right. So our graph should do something like this. And these sketches should be pretty rough, okay? Don't worry about it being like, super accurate here. We're just trying to get like a sketch of the graph down. So just get an idea of what it should look like. So we're going to go up. We're actually going to bounce off the x-axis at 0 because we've got a multiplicity 2 on that one. And then we'll pass through this 4 and then kind of go up like that. All right, number 18. So this one's not factored, so let's go ahead and factor that if we can. So g of x is going to equal, let's see, can we take a 3 out of there? You know what? First, before I even go there, I'm going to write this in standard form so I don't have to do two things in one step here. So yeah, it looks like we can factor out a 3, and to be more specific, a 3x squared. And when we factor out that 3x squared, we get x squared minus 48 divided by 3. 16, does that seem right? 3 times 6 is 18, yeah. So minus 16. So our zeros here, or our x-intercepts, are going to be 0 from this first one, and that's actually going to have a multiplicity of 2. So we're going to bounce off the x-axis there. And this one, if we add 16 and take the square root, we're going to get plus or minus 4. So we're going to get 4, and we're going to get negative 4. There's no constant here, so the y-intercept is 0, which again, if you have an x-intercept of 0, you know right away that your y-intercept is going to be 0 as well. So we've got a point here, we've got a point at 4, and we've got a point at negative 4. Here's 4, negative 4, We are going to bounce off the x-axis at the origin because of the multiplicity. So let's look at the leading term and figure out our end behavior here, and that'll kind of guide the rest of the graph here. So the leading term has an even degree and a positive leading coefficient, so it's going to be going up and up. It's going to go towards positive infinity in both directions. So let's see here. Even degree, positive leading coefficient, so I can just borrow, so I don't have to retype all this. Oh, whoa, that's too much. I don't want all that. Is it not going to let me copy just this little section right here? It wants to grab those zeros for some reason. That's okay. I'll just go back and erase that. So let's go ahead and just real quickly erase this extra stuff that this 1/2. No, I don't want that. I don't want that. I'll just redraw the 4, I guess. Okay, so yeah, we're going to be going up in both directions. We're going to bounce off the x-axis at the origin. So here's your graph. It's going to go up this way. It's going to go up this way. These are both single roots, so I'm just going to pass right through. And then I do want to bounce off of the origin. So I get a little W-looking graph here. All right, and there's number 18. For number 19, looks like we can factor out an x just off the bat here. So we get g of x equals x and let's see, times negative x squared plus 4x minus 4. And actually, you know what I'm going to do? I'm actually going to make this secondary factoring a little bit easier. I'm going to factor out a negative x just to make this a little bit easier to factor. If it can be factored. Let's see if it can even be factored. My instinct says yes, but let's make sure that is correct. Let's see here. Yeah, this one can factor. This is going to be x minus 2 times x minus 2. So we get 2 zeros here, 2 x-intercepts, or yes, 2 unique x-intercepts here. We get 0, and we get positive 2, and that positive 2 is going to have a multiplicity of 2, so we're going to bounce off the axis at that x value. We have an odd degree and a negative leading coefficient. Did we have another one like that? Odd degree? Nope. Oh, yep, we did, way back here on number 10. So yeah, we've got an odd degree, negative leading coefficient, so we're going to be going up to the left and down to the right. Okay, so let's start plotting what we know out. We've got our x-intercept at 0, meaning our y-intercept is also 0. Don't really need to plot, if it's on the origin, I'm not going to be a stickler for labeling 0. It should be implied, but I'm just going to write it anyway. And then I've got a duplicate root at 2, so let me label that. Okay, so these are my only x-intercepts. As I go to the left, I'm going to go to the leftmost 0, and I'm going to go up on that one. I'm going to go down on this one, and since my x-intercept of 2 has a multiplicity of 2, I'm going to bounce off of that and then do something like that. And there's our sketch for number 19. So number 20, it's already factored. Super nice here. Now when we talk about that y-intercept, I want to show you a quicker way of getting that. But yeah, so my zeros here, let's start with that, are going to be at 1 and then plus or minus 4. So negative 4 and positive 4. And it looks like that positive 4 one, we've actually got 2 of these factors. So this is like an extra times x minus 4. So this positive 4 actually has a multiplicity of 2. Okay, so as far as getting the y-intercept and the end behavior, when you have this like long factored out polynomial, you don't, when we just had 2 factors, number 17, it was easy to just distribute this and just come up with the entire polynomial. But when you have 3 or more of these binomials, it's not really worth multiplying it all out because the only things that are going to affect your sketch are the leading term, which will determine the end behavior, and the final term, the constant, which will determine the y-intercept. So let's start with the y-intercept. Okay, to get the y-intercept, like we would normally multiply this whole thing out, but we don't want to have to do that. So instead, all you need to do is just multiply all of the constants in each factor. Now, if one of the factors is squared, you got to make sure to multiply that twice. Okay, so to get the y-intercept here, it's going to be -1 times 4 times -4, twice. Okay, so -4 squared. And so my y-intercept is, let's see if I can do this. That would be -4 times 16, so that'd be -64, if I'm not mistaken. Yeah, see, 4 times 4 would be 16 times 4, yeah, 64. Okay, so the y-intercept is going to be -64. So we've got that. Now for the end behavior, we're doing kind of the same thing to get as the y-intercept, except we'll just multiply out the leading terms. Okay, so to get the leading term, I'm going to multiply x, and then x squared. Okay, can't forget that this is actually happening twice. So let's see here. I'm going to say the leading term, so this way I don't have to multiply the entire polynomial out, is going to be x times, let's see, let's go over here to equation here. X times x times x. Now if there was a coefficient on one of these, like if it was 2x, you would throw in a 2x there. And then that last one's squared. Or you could just write, you know, times another x. Either way is fine. But no matter what you, which way you do it, you're going to get x to the fourth. So my leading term is x to the fourth. So that means I have a positive leading coefficient and an even degree. Okay, even degree, positive leading coefficient. So my end behavior is going to be up, up. Okay. Let's see. Grab all of it. Oh, nope. It wants to grab the whole thing again. I don't know why it's doing that. Not a big deal, but it's going to be very similar to this. Oh, there we go. I just grabbed what I wanted. Even degree, positively leading coefficient. So now let's go ahead and start plotting everything. We've got our x-intercepts at 1, at 4, should be somewhere over here, and -4. So I've got a point here, here, and then I will have a bounce occurring at here because of that multiplicity. So don't lose track of these multiplicities. It's very important for when you're sketching the graph that you remember that the function is going to bounce off the x-axis at that value. So my end behavior is up, up, so I'm going to start with that. It's always good to kind of start with your end behavior once you got your intercepts down. My y-intercept, which I didn't plot on here yet, is going to be -64. It's going to be way, way down here. And I know this doesn't look like it's to scale, and that's because it's not. Don't worry about it being to scale. So the only bounce I have here, the only multiplicity I have is on this x-intercept of 4. So I know I'm going to bounce here. And now I'm going to just pass through this one. I need to go all the way down to 64, and then I'm going to come up and then have like another pass through here. So your graph should look something like that. All right, I think that's all the graphing. The last page on here is about writing the equation. So we did this at the very end of the lesson. So let's go through these couple of problems here. For number 21, the roots are -2. So we just have 2 roots with a multiplicity of 2. So as we write this function, we're going to start with the roots. So if we have -2, that means we're going to have 2 duplicate factors, x plus 2 and x plus 2. And to figure out, to deal with the y-intercept, I'm going to take care of that last. Okay? So I'm going to just start with this. Oops. I guess I have plenty of space here. I don't know why. I'm trying to save space. So this is going to have the wrong, like when I multiply this all together and I get x squared plus 4x plus 4, notice the y-intercept is wrong. Okay, this is not the correct y-intercept. So to adjust for that, what we need to do is we need to multiply this polynomial by a constant so that this last number is a 1. So, when you think about that, you say, okay, well, what do I need to multiply 4 by to get 1? And the answer to that question is 1/4. So really what I want to do here is multiply the whole function by 1/4, and that's not going to affect any of my roots, so I don't need to worry about that. But what it will do is it'll fix the y-intercept for me. So I've got 1/4 times x to the x squared plus, well, 4 times 1/4 is 1, so it's just going to be x plus 1. And there's your function. So this function will have the two roots being -2, and they're the same. Let's try to make this fit a little nicer here. And it also has the correct y-intercept. So usually you want to go through and come up with the factors first based on the roots, multiply those out, and then adjust as you need to for the y-intercept. So we'll do the same thing for number 22, although we don't have any multiplicity here. I'm going to start with the two roots being x plus 8 times x plus 4. When I multiply those together, I'm going to get, let's see, x squared plus, let's see, 8 plus 4 is 12, and 8 times 4 would be 32. Is that right? 12 and 32, I think that's right. But obviously the y-intercept's not right. So to make sure that the y-intercept's right, we need to say, okay, well, 32 times what is -3? So after the other one, this one was kind of obvious, but for number 22, I don't think it's as obvious that 32 times what is -3. So we want to solve this kind of like an equation and divide by 32. So we get -30 over 32. And so this is going to be our sort of factor. It's kind of a crazy looking factor here. Or let's see here. There we go. So we'll just multiply our entire function by that number, and hopefully that will fix our problem here of the y-intercept not being correct. So we get -3 over 32 x squared plus, minus 12 times 3 would be 36 over 32. I'll come back and reduce that in a minute. And then, then -3, so that'll work out. Now, if I want to reduce this one, I don't think the first one can't be reduced, but the second coefficient, let's see, these are both even, so we can at least divide by 2, so 18 over 16. And I guess we could divide them both by 4 from the beginning. So we could do that again and say 9 divided by 8. I think that's right. And so here is our function. It's got the correct zeros, it's got the correct y-intercept, so we should be good there. So number 23, we got all kinds of roots going on here. All right, so the first one is going to be -3, so we've got x plus 3, and then we've got 0, which is just going to be x, but multiplicity 3, so it's x cubed. And then our last one is x plus 1, or minus 1. So let's, first I'm going to multiply those two binomials, and I'm actually going to put this x cubed out to the front. And let's multiply that together. So that would be x squared plus 2x minus 3. And then if I distribute that x cubed in, I would get x to the 5th plus 2x to the 4th minus 3x cubed. Now, let's see, the y-intercept here is 0. So actually, I lucked out. Okay, I don't have to multiply by any coefficients here or any constants because my y-intercept is already 0. Okay, so that's it. There's nothing more I don't need to go any further. All right, and that's the last problem of the homework. I hope you enjoyed it. If you guys have any questions, please let me know. Now there was one last thing. If you're sticking to the end of the video, I did notice this is very minor, but as I was describing the end behavior on 9 through 12, I think, I did not pay attention to the name of the function here. It's like g of x, and originally I had written this as like f of x, but it should be g of x. Not a big deal, like these answers should still be legit, but just a little heads up if you made it this far. I wanted to make sure to get that correction in there. But other than that, y'all have a great day, and I'll see y'all next time.